everyone. My name is Hoffmann, and before I actually dive into the technical parts of my talk, I've got a quick question. Who has heard of Conways Law? Okay, surprisingly much people. I'm still going to give my interpretation of Conways Law. It basically says the system designs are going to resemble the organizational structures at some point in time. So this is why I'm going to give a short introduction into the structure of our company, which is the HUK-COBURG. We are a German insurance company targeted at consumers. We are the largest car insurer for German consumers. We've got about 12 million customers and 10,000 employees. Within HUK-COBURG, there are multiple departments, even multiple IT-related departments, and we've got about 800 people working there in IT-related jobs. So we are certainly not some kind of startup. Rather, we have lots of teams, lots of policies, lots of regulatory stuff, high data security policies, and so on. One of these IT-related departments is the Linux platform development team. And we would describe ourselves as some kind of managed infrastructure as a service provider. So we provide Linux machines to our internal customers, and we manage around 900 servers based on Red Hat Enterprise Linux. These servers are distributed across 2 main data centers. I am one of the 10 people in exactly this team. I joined in 2016, and I would describe myself as some kind of Linux and open source enthusiast. So much for the organizational part where I work. We've got lots of other teams, as I said. So we've got application owners who run databases, who run web servers, who run insurance software. And these application owners are the ones who use our Linux servers as the base. We've also got a dedicated operations team which handle the on-call situations, which I'm going to describe later. So now let's dive into the actual technical parts. I'm going to describe our Prometheus setup, how we run it, what our basic configuration looks like, but I'm going to focus on the parts where I think our setup is special. So let's start with scraping or with the actual Prometheus servers. When we started, we thought about how many Prometheus servers are we going to run and where should we place them? The common recommendation seems to be run your Prometheus servers as close to the monitoring target as possible. But what does close actually mean? We thought about this and we came up with multiple ideas what this could mean. We first thought about firewall zones, and we quickly noticed that we've got lots of firewall environments and some of these environments don't even contain any virtualization or container infrastructure. They only contain 2 or 3 servers, and it certainly would not make sense to run Prometheus instances for high availability there. So we thought about other meanings of the word close. Should we run it on the same network switch cluster? Should we run it in the same data center, which most people seem to do? And what we actually decided is that we should run from a responsibility perspective. So we decided that we should run a central Prometheus instance, and we would run this as a pair of 2 servers distributed across our 2 main data centers. So this is how it looks, and we monitor all servers from both data centers. So there's not two pairs of these, there's just 1 pair. This has the benefit of providing insight into the network. So if we really should have some discrepancies between the data centers, we are going to see this using these instances. So I'm going to put up some numbers, and you will notice that our Prometheus setup is actually not that large. We run it on 2 virtual machines with 4 cores, with 20 gigabytes of RAM and 1 terabyte disk space. We handle 1.7 million time series with about 30,000 samples per second. We've got a pretty standard scrape interval of 60 seconds. We use the file service discovery for service discovery and have about 2,600 entries there. We've got lots of alert rules, which we write by hand, obviously, and we've got lots of recording rules. These are partly generated from other systems, so these are used to provide further metadata into Prometheus. So now that we've got our Prometheus servers, where should we scrape the metrics? How should we reach our monitoring targets? As that, we have a high security environment. Everybody's going to talk about, well, you can't do that over plain text formats. So the common recommendation seems to be, well, place a reverse proxy in front of it, use TLS, and get all these certificates and stuff. We thought about this approach, and we quickly noticed we've got already lots of monitoring on agents on our servers. We've got security scanners, we've got license management tools, and it's only getting worse, though we really try to keep the number of extra agents on these servers down. So how do other, well, monitoring systems solve this problem, or what does a typical Linux server look for us? We ran nmap, and we noticed there's one service running there already. It's SSH. Other monitoring tools use SSH and run some kind of command on the target server to get their data. And we thought, well, can't we do something similar? Maybe not running a command, but using at least SSH. SSH provides us authentication, encryption. It's easy to lock down. We have an established mechanism for SSH keys. We don't have to, well, get TLS certificates from different CAs in our environments. So SSH looked like a good idea, but Prometheus does not support SSH. Luckily, Prometheus is really flexible. So we've got our Prometheus server, we've got our monitoring target, and the monitoring target runs SSHD, and it runs all the exporters. So how do we get Prometheus to use this way for access? All we need is to use Prometheus proxy feature. It has a config option which says proxy URL, and we can, well, plug in anything we want in this case, and we came up with a small daemon which we call sshified, which simply provides an HTTP listener to Prometheus and translates all requests from Prometheus to an SSH tunneling request. So this way we wrap all the metrics accesses within this SSH tunnel, which is easy from a firewall point of view, which provides us the authentication and encryption. Of course, this also only makes sense if we limit access to the actual exporters. So Node Exporter will probably start with binding to the public interface by default and exposing all the metrics on a public port. This is something we had to keep down. So we lock all exporters to localhost. And we even deploy IP tables rules to further restrict access to only some specific user on the system. So what exporters do we actually run? Well, Node Exporter is something you probably all know. We also make heavy use of the text file collector feature. We mainly use it to fill gaps where Node Exporter does not yet support specific parts, such as certain error situations in LVM, in multipath constructions, in SAN-related monitoring. We've also got a small script framework which makes it easy to plug in scripts so that other people from the other application teams can just write some small script which outputs some metrics, and Node Exporter will pick them up. We do run Node Exporter as root. This may surprise you, as there are recommendations not to do this, but we have reasons for that. One of the reasons is that we like to lock down our file systems really much. So a normal user would not be able to see each file system on the server, and we would have to teach people to configure monitoring access for them, and we would not even notice if someone forgets to do that. So Prometheus, or the Node Exporter in this case, is able to see all file systems this way. Also, we make heavy use of the systemd exporter to monitor services, and the systemd exporter has a custom feature which uses a private socket to well, access systemd. So the connection between Node Exporter can either go over dbus or it can go over the private socket. And the private socket turned out to be much more reliable for us, especially under load situations. We still have lots of services which are not within systemd. We also got some legacy systems. So this is where we run process exporter to do some process-based monitoring, but we really like to get rid of this part. We use another exporter called multi-log exporter, which is used to extract metrics from, well, proprietary application logs. This is comparable with the mtail exporters from Google or the grok exporter, which support a custom matching support. We also use a black box exporter, and we do not run it in a central place, mainly only as well for firewall reasons. So we run this part as close to the target as possible. So a machine exposing a web server may get also black box exporter, and we will at least see if the web server works correctly. For us, this is okay because we have other monitoring tools which monitor the whole place from the customer view to the actual load balancers which return the actual data. So now that we've got the Prometheus setup covered, I'm going to dive into the alerting part. We use Alert Manager, as probably most of you do. And our Prometheus instances send all the alerts to Alert Manager, and we've got a fairly simple routing tree. Our routing is based mainly on the alert name. We've got three categories. We've got Linux platform alerts, which are targeted at my team, and we've got Linux server and application alerts, which are targeted at the application owners. So a custom example would be a platform alert could be something like SSH daemon going down or the connection to our Active Directory going down. This is something that we would resolve, but we also have lots of alerts which the application owners have to solve, such as a filling file system or something like that. We use two integrations. We use a webhook receiver and the email receiver. And the webhook receiver is also the place which we use to forward all Alert Manager alerts to our central monitoring. So in our case, Prometheus is targeted at the Linux monitoring, but at HUK-COBURG we run lots of other systems like network devices and Windows servers and so on. And this is all collected in a central place. And we have a custom daemon which translates the Alert Manager webhook requests into a syslog event for this central event management. The central event management is also the place where incident creation happens, where paging happens, and where we've got some monitoring to catch the case when Prometheus dies. We also make use of silencers, and this is done by using our proprietary server inventory, and the server inventory uses some kind of maintenance mode, and we sync this maintenance mode and translate it to silencers in Alert Manager using a custom Python script. For graphing, it might surprise you, but we use Grafana. Our main challenge was building some kind of multi-tenancies there. So we have this Grafana setup, but what happens if John accesses our Grafana instance? We wanted him to see only the servers which are relevant for him, on the dashboards which are relevant for him, and this is the solution we came up with. So John accesses a web server, Apache HTTP in our case. We authenticate him using mod LELP and mod auth-curb. And after that, we tell Grafana, well, this is John. So Grafana knows this is John. We've got an organization in Grafana for John, and we've got this for all our employees which use Grafana. And we do this because we do not point this organization's data source in Grafana directly to Prometheus, but instead we point it to a custom service called Prometheus-filter-proxy. And Prometheus-filter-proxy translates all these requests and maps a special label onto all parts of the query. So if John is going to ask for the up metric, Prometheus-filter-proxy is going to translate it to up, but only for time series labeled with owner John. This is not some idea which I came up with. This is an idea which I stole or borrowed from some of the tickets. It may be Brian who posted it there. So this is only some implementation of this idea. Of course, we do not do this all manually. We've got lots of employees, and so we've got lots of Grafana users. So we use some kind of template organizations where we do our dashboard changes, and we've got a job which manages all the dashboards of the actual owner organizations. We also run this setup twice, basically for high availability, so that we can perform maintenance work. And we accomplish this by running a floating IP address. So this is always on the left side, except when there's maintenance, it is moved to the other side. And we keep Grafana in sync by just rsyncing the Grafana SQLite database. We know that there are more sophisticated ways, such as running Grafana together with some kind of database, which is highly available on its own, but we really wanted to cut down dependencies at this place. So, and lastly, these were the parts about the common Prometheus infrastructure, but I also want to provide some insight into how we integrate Prometheus into our environment. So I've got two examples there, and the first example is about integrating Prometheus into our existing config management. We use Puppet. others have used Chef in their talks. We use Puppet, and we use Puppet to deploy all the servers, so it was a natural choice to use Puppet to deploy all the exporters we need on these machines, and it was also a natural choice to use Puppet to configure Prometheus itself. So Puppet takes its own, database, or flat file database, which is called Hyra in Puppet speak, and this contains all our scrape configs and our platform alerts. So these Linux platform alerts come from this place, and we can also use Puppet to distribute server or role-specific alerts in this case, so that we can have custom alerts for databases or custom alerts for web service. This is an example for Prometheus being integrated into the configuration management, but I have a second example where we made use of the features of Prometheus in another process. I hope that most companies do have some kind of patch management process, at least we do, and we try to automate as much as possible. This means that our patch management process should be automated as well. So we've got some internal development and staging environments where we pull new operating system patches or releases, new system software and so on. And we use Prometheus to detect common problems there, like the server no longer coming online after such an update. But we also run custom benchmarks to see if there are some performance regressions. And we started to introduce this when all the hype around Spectre and Meltdown came up. So this is a place where we run Prometheus and can detect anomalies before we roll them out. This is the first place where we use Prometheus in the patch management, and we use it also in a second place when we actually update application servers, such as our main website. Then the changes will first go out into a development machine, and if there is anything which comes up in the alerting, then our patch management process talks to Prometheus, asks, is there anything special about the development server, and if there is, it's going to stop the deployment into the other environments. And this even works in production, so we can ensure that if one server is down because of other maintenance or some problem, then we are not going to patch to the other one and leave us with no servers to serve the actual customers. So these are the parts which work good for us, but we are also not done. So we do have some ideas about long-term storage. We currently keep data for about 1 year, and this can be problematic if people try to process large time ranges, and we would really love some solution for downsampling the data. We currently have some kind of janitor process which talks to the Prometheus API and deletes all metrics which are not used in any dashboards or not used in any rules, so that these metrics are only available for 30 days, and only the other metrics are kept for longer. We also want to look into dashboard performance optimizations and have lots of other ideas. So to sum it up, we are very happy to have implemented Prometheus. Prometheus provides us flexibility, even in our regulated environment, in our high security environment with lots of policies. It made it possible to offer multi-tenancy for our teams, so that each person only sees the relevant parts for them. And Prometheus is really good to integrate into other processes, which also helped us. So this being said, thank you very much to the Prometheus developers, community, the PromCon organizers, and thank you for listening.
Hi, I have two questions about the Prometheus filter proxy.
Yep.
The first is, does that work? Does it inject the correct owner label into all, any kind of complex query that comes through? And the second is, how do you ensure that the owner labels are actually part of the scraping logic? How do you make sure they actually get added in?
Okay, first, the first question. I hope that we have a robust solution in this place. We are using the actual PromQL parser, so this is not some kind of a regular expression hackery or something. We use the official Go PromQL parser and try to match each PromQL data type and so on and inject this label there. And we have not found cases yet, but this project is open source. You can have a look at it, and if you find something, please tell me so that we can work it out. And for the second part of how we ensure that the owner's label is attached to all the metrics, This is part of our file-SD service discovery mechanism. So we use Puppet to pull this data from our server inventory and use Puppet to write a config file which is used by Prometheus and contains this owner's label per job.
Yep. Oh, thank you. Yeah, I'm here. Yeah. Thank you. I have a question about sshified. Sorry.
I call it sshified, and I noticed the name is not really good pronunciable. So,
okay.
Yeah.
I have two questions. First question: do you restrict SSH access on the target host? I don't know that you don't run every command maybe or something like this. And the second question is why not run some maybe wide-based TLS proxy on the target host as well, not giving full SSH access for someone who has access to Prometheus host?
I haven't got the second part. I'll answer the first part and have you repeat the second part. The first part, how we lock down SSH access. Well, basically we use normal open SSH methods. So we use public key authentication, and we can put some restrictions in the authorized keys file, such as disabling all command usage and only permitting the port forwarding, which is what is required in this case. So there's no shell or anything open. It's just the port forwarding.
Yeah, okay. The second part was about why not use something like Jinx or maybe line Jinx on the target host. And
Nginx,
yeah.
Okay. Well, basically, because we would have to run it on all the target hosts. As said, this is a common best practice. You can do that. And in our case, we decided that it would be too much overhead. Even by using Puppet, we would have to run it everywhere. There can be failures. It would have to be updated and so on. So we just want to try to keep the number of agents on these servers low. So we went for this solution, which places this in a central place.
One more question, yeah. Do you find any hard limit on this SSH pipe you're using? Like, how much can you ingest?
Not yet in production, and the CPU usage is also okay. We ran into one problem once, and it was related to file descriptors. Since that, we have implemented a metrics endpoint for sshified, so we know about its state, and we have an alert on it, and it doesn't happen anymore. And regarding the actual throughput, which works, I don't have any numbers ready, but the GitHub page maybe contains the actual numbers. At least it contains some scripts for benchmarking, so you can quickly run it yourself and try to see how many connections it will handle.
Hi. Sorry, with sshified, do you have a way to restrict only the port that exports metrics, or does the user have access to all the ports on the machine?
On the, do you mean the machine which we are monitoring?
Yeah,
the target.
The target, yeah.
We use the exporter restriction for binding to localhost only, which limits all access to the machine itself. And in addition, we deploy IP tables rules where we have an owner match target, which limits all access only to the specific user which we use for sshified access.
Any more? 3, 2, 1. Thank you very much.